Okay, let's take a look at problem 4. It says interpreting a quadratic graph. Bridges. The New River George Bridge in West Virginia is the world's largest steel single arc bridge. You can model the arc with the function y equals negative 0.000498x squared plus 0.847x, where x and y are in feet. How high above the river is the arc? So we want to figure out, so if this is my arc here, and this is the equation, the quadratic equation that they gave me, and I have here is my height of my arc here. How high above the, how long is the section of the bridge above the arc? So we want to know the length. Same length here through here, so it's the exact same. All right, so first we know we're given the quadratic function. And I know that basically if I put my quadratic function here, this is what it would look like in terms of a graph. And so I basically am asking for the vertex. So the vertex gives me the height, right? So here's my vertex. It can tell me how high, this is my highest value on my y-axis. So in order to find the vertex, I can use this to find my axis of symmetry. So that's x equals negative b over 2a. And I just plug in what my b is. Going back to the equation, b is 0.847, so I put 0.847, and it's the negative of that, divided by 2 times the negative of 0.000498. Okay, when I do all of that, a negative times a negative cancels out, turns positive, and I get 850. So 850 is my x value. When I plug my x value into my equation, so this is the equation, the quadratic equation I plugged in, I can find y, and I get 360. So my vertex is 850, 360. So that means the height would have to be 360. The arc is 360 above the support. Now to find, they give me this. They let me know that the this part is 516 feet above the water, so that I can add that 360 to 516 to get 876 above the water. All right, and then it says find the length of the bridge above the arc. So it says the x coordinate is half the length of the bridge. So here, from here to here is 850. So if I want to do the other half of the bridge, I need to add another 850, which is going to give me 1,700 feet. All right, so let's take a look at the guide and see if we can do it on our own. Okay, so please forgive me for not pronouncing this correctly, but it says the Zazoa Bridge in China is the oldest known arc bridge, dating to AD 605. You can model the support arc with the function f of x equals negative 0.001075x squared plus 0.131148x, where x and y are measured in feet. How high is the arc above its support? So this time we're just looking, if we're looking at our arc, I'm just looking for this height right here. Okay, and so that means that when I look at my graph, I'm just looking for the height. I'm looking for my y value, looking at my axis of symmetry. So going here, I have my function is y equals 0.001075 x squared. Making sure I write this correctly. Negative plus 0.131148x. To find the axis of symmetry, my x value is equal to negative b over 2a. So that's negative 0.131148 divided by 2 times negative 0.001075. We can put that in our calculator. Negative times a negative is a positive, so I'm going to go ahead and not put those negative and positives in. So a negative divided by a negative times to a positive. So I get 1.131148 divided by 2 times 0.001075. And I get 60.999. I'm going to round up to 61. So it's going to be x is around 61 feet. Okay, so now I need to take this 61 feet and plug it back into this equation. So that'll be 0.00 or negative 0.001075 times 61 squared plus 0.131148 times 61. I'm going to cheat a little bit, and I'm going to use my free graphing calculator. Oops, sorry, I did it. My free graphing calculator at www.desmos.com, and I went ahead and I plugged in the equation 0.001075x squared plus 0.1311 f of x, and I made it f of x, and I asked for what is f of 61, and it gave me 3.999. So I'm going to say my y value is 4. So y is around 4 feet. It's a really short arc. So let's make sure we answered all the questions. Okay, it says, why does the model in part A not have a constant term? So what does a constant term represent? Constant term represents my y-intercept. It's the place where my y is, my graph or my arc is crossing the y-axis. Well, it doesn't cross. Well, not having a constant term means that I don't have a y-intercept. So I hope this helps.